Hello and welcome everyone. In today's episode, we are going to discuss the value equality. So while coding, we often find ourselves questioning the equality of different objects, like the object we have right here is actually equal to the one we have right here. So what does that actually mean? Let's understand it. So it's important to note that the objects can be stored in various memory locations, such as main memory, the cache memory, or even a server. So comparing the records based on their values or attributes is called value equality. In that aspect, Dart programming language is same as other programming languages, but the way it operates is a bit different. For example, Dart will always return false while comparing the two objects of a same class having same values with having a non-const constructor. For example, create a class with one string attribute, create the object of it, pass the same value to them, print them as equal, and this will result in false. So, as we talked about, the objects of a same class having same values with a non-constant constructor, Dart will consider them they are not equal. So in contrast, while having a class with a const constructor can solve our problem, right? Again, same example. Put the const right before the constructor and replace the const on final. What the const does is it tells the Dart to create only one instance of a class for the given values at compile time. This time, if we compare p1 with p2, this will result in true. This is great, but for achieving such small tasks, as const constructor creates only one instance of a class at compile time, so it's not suitable for the calculations and the dynamic operations at runtime, such as loading data from server or from cache. And this is only suitable for the fixed and non-values. The const constructor objects are stored in memory and can be reused when needed. It can save memory in some cases, but can also lead to the increased memory consumptions if the objects are unnecessarily duplicated. One more thing about const constructors, they can still lead us to the false result when their objects are not created with the const keyword. So this time, if we remove the const keywords while declaring the objects of the class and put the final keywords, this will result in false, because the final keywords allows the variables to be assigned at runtime and compares the references of the objects instead of comparing the values. Therefore, these objects are not considered compile time constants. The default behavior of the equality operator is to check if two objects have same reference or memory address, which is false because the final objects have different memory address. So that const constructors comes with limited flexibility. And another option is to use the equality operator. This first checks if two objects have same address in memory, then checks if two objects have same class, and finally compares their attributes. But writing this code with every class where we want the value equality is not so good, and that's where the package Equatables comes in. But before going through Equatable package, let's understand some hashcodes. Just like the books in the libraries, each book has the ISBN or the International Standard Book Number assigned to each book. Or let's make it more simple. Let's take the example of the database. In the database, each record has a unique ID assigned by the database. Same like that, all of the Dart objects has a hashcode assigned by the Dart VM during instantiation. So if you're not a beginner, you may have definitely used the hashcode property for evaluating hashcodes of Dart objects. But these hashcodes are not interesting. These are just the pseudo-random numbers which can be changed along with the program execution. But there is one benefit of the hashcodes. They can become the reason of simplifying the equality overrides in the classes, especially for the classes which have a lot of attributes. For example, if we have a class person with three attributes, name, age, and bio. First, we override the hashcode getter and pass the hashcodes from all of the class attributes. Now our equality operator without the help of hashcode looks something like this. But as now we have the hashcodes, we can do something like this, not comparing each value separately but comparing their hashcodes. That's great, but still there is so much code. But that's okay, because we have the Equatable package to solve this problem for us. With Equatable, just extend the class with Equatable. Override one getter whose return type is list of objects, name props, and pass all of your attributes inside. And just doing this, create two objects, compare them again, and this time it will result in true, and our problem of equality is finally solved without writing so much code. Since everything in Dart has hashcode, so it means they can become keys in hashmaps. The hashmaps, which in Dart are commonly called the simple maps. So again, create a class, say person, with an attribute, then create a map and pass the object as a key. Assign them some value. Check if it contains a key by passing the fresh new object reference, and it will return false. Because this is new fresh instance and the one we set as a key both have different pseudo-random hashes assigned to them. So same like that, make it equatable, and this will solve our problem by returning true. So that was all the basic understanding of value equality. So having this understanding, let's go and understand them in more depth from code. So we have this simple application where we have a simple scaffold, a column where we are returning some text, and we have two buttons. And in the pubspec.yaml file, we use the Flutter block for managing the state, and we use also the Equatable, but we are not currently using it. We are only seeing how the value equality can help us in our code and thus improve the performance of our application. So in the main.dart, we have the block builder, which is listening to the current changes when any new state emits. So first let's go to the qubit, where we have a qubit action stat. The action stat has a value of string and passing it in the constructor which is required. In the qubit, what we are doing in here is simply we have a method, and block we have events, but in qubit we have simple methods which can be called in the UI. So we got this method of change data. So anytime this method is called, it emit a new action stat with the data we passed in. So that is a simple qubit in here. In the main.dart, using block builder, we are simply listening to these new changes when the new state is emitted. So we have provided the block so that it can be accessed in the context of the home, and then so we have a block provider in our context. So here in the build we are accessing it like this. So now this time we have two buttons in here. The one is called change 1 and the second is change 2. So the first one is called is change the data of the text, where we are returning here Flutter is awesome. The second one is doing Dart is awesome, and that's it. So without value equality, if we try it and open the console, with each button we are calling the change data called, for also the second one change data called, and when the block builder is built we call the block builder called. So let's see what is happening in here. So when we say change 1, you can see the Flutter is awesome appears on the screen. The change data was called and the block builder was called. Next time, if we again click the change 1, again the change data was called from the change 1 and also the block builder was called again. The same will be when we click this again and over again. The block builder will every time listen to the changes, and even though we are emitting the stat with the same value, we don't have any value equality in our stat, so every time it listens to it, it will emit it and will rebuild the UI. So that is the behavior without value equality. And the same will be when we click change 2, same block builder is called and change data was called. And if you keep clicking this, block builder will be keep calling and the change data will be also calling. So that is the default behavior in order to overcome these rebuilds of the UI every time when the new stats was emitted and the data was equal in the previous and the newly emitted stat. We have to use the value equalities in our stat. So you can use also, you can override the hash code, compare the class, the attributes, and again their hash codes. And if you don't want this, you can simply extend the action stat with the Equatable and simply override this and pass the string data in the list. And that's it. Now hot restart your application and go for testing it again. So when the application hot restarts, we have again nothing because initially we have only simple string inside the stat data. So open the run console and open the running device. So this time if you click the change one, the Flutter is awesome came in here on the UI. The block builder was called along with the change data because when the button was clicked, the change data was called. So this time if we click the change data again, only the change data will be called but the block will not build because it compares the old and the new emitted stat. It has same values, it will not rebuild. But this time if we click the change to, this time only it will rebuild the stat because now we emitted the stat with the new value, that is the dot is awesome. And now if you keep clicking, it will only call the change data and will not rebuild the stat if the values in the previous and the newly emitted stat are equal. So that is the beauty of equality, which can help us to improve the performance of the application and also can help us in many more aspects of our development. So I hope this video was helpful. And one more thing, follow eTechViral on Instagram and LinkedIn, where we on daily basis upload the informative content and you can learn many things from here. So that was it for this episode and I will see you in the next video.